Yeah, I can see many participants have joined in, and yeah, let's just wait for a couple minutes, and we'll start with the session. Hello, Sankiri, Karthik. Hello, Fiddle. Hello, Kavya. Hello, Vedang. I hope everyone is doing good. It's a weekend, so I think everybody was chilling, except Sir because he's really busy, as I said. And despite being this busy, I'm really glad that he managed to schedule a talk with us, and I'm pretty sure everyone, including me, is excited for this talk. And we'll start, I think, at 4 exact.
Yeah, we'll start at 4. Also, guys, there will be a Q&A section available there in the chat box. So make sure that you keep posting your doubts there during the session, and Sir will answer them.
Yeah, and make sure you tell your friends as well. Like if they have not joined yet, make sure to remind them that to join here, because this session, I'm pretty sure it will be really good. And yeah, we'll start now. Yeah, Aniket.
Yes. So, first of all, a very good afternoon to everyone. We, the members of Android Club and Google Developer Student Clubs, are excited to welcome you all to this amazing event, Appify. I am Aniket Kulkarni, and today I will be hosting this event along with my co-host, Amman Verma. Appify is the final event of the 3-day long online fest Revelation organized by Android Club in collaboration with Google Developer Student Clubs, Zero Bugs Club, Music Club, and Comedy Club of VIT Chennai. So far, we have received an overwhelming response from your side in all the events that have been conducted. So we thank you all for giving such an amazing response and showing your interest in learning. Coming to today's event, Appify is an event for all the budding app developers and all those who are interested in app development and building a career in app development. Today's session will cover all the topics including SuperApps and how to become a successful app developer in the near future. Now I hand over to Aman to take over.
Yeah, thank you, Aniket, for that part. And Hello everyone, I am Amman Verma. I am the app dev lead at GDSC VIT Chennai, and I'm really excited that we have Mr. Pavan Podila here, and he is currently at a post of head of architecture at Tata Digital, and he has had at most of I think at least of 20 years of experience in this field, and he's very experienced in mobile development and web development. He has written several books on state management, and he's also a speaker at Google Developer Experts, and he has given a speech in Google Developer Summit, India Summit in 2018, which was regarding I think it was something like thinking the UI, if I'm not wrong, sir. So that
thinking in UI.
Yeah, yes, sir. So I am really excited for this session. I am really excited to learn more about app development in general, and I would like to request Mr. Pavan Podila to take over from here. And yes, sir, that's pretty much it from our side. You can take over whenever you feel like.
Sure. Hope you guys can hear me well.
Yes, sir.
Yes,
All right.
sir.
Yeah, so I think this was more like a conversation which I wanted to have with you guys. So I don't want to be the only one speaking here. I think you guys have prepared some sort of questions, right? Aman and Aniket already. So maybe we can go through them one by one, or take it in whatever order you feel like, and I can go on and answer that. I think it's more of an open platform for you guys to ask me questions rather than me giving you a long, boring speech about app development.
Yes, sir. So regarding app development, I am pretty sure that many of here are learning app development as a career option. And being an app developer, like I have made some apps. I have been learning Flutter for the past 2 years. So I actually really like Flutter. Back in the day, I started in 2019, so I really like Flutter. So I started out trying it out in a workshop, and then I really dived into it. I enjoyed its feel. So I would like to get your insights on Flutter if you have tried it. If you think it's a good framework to begin with, or would you insist on some other frameworks such as some native development, such as Java, Kotlin, or some other like Swift in iOS? So for that, what are your thoughts, sir?
Mm-hmm. Yeah, so see, if you look at the UI space today, a lot of the toolkits are doing pretty much the same thing in terms of the fundamental building blocks, right? It all started with React, where you had component-driven development, unidirectional data flows, that data always flows from the top to bottom, and then keeping the state as the primary means by which you render UI, right? So UI is not something which holds the data, but data is separate from the UI altogether. And whenever data changes, the UI updates and automatically changes its visual presentation, which is how it's supposed to be anyways, right? Kind of mimics the human body in a lot of ways. So that trend continued in other frameworks as well. Then React came in and then added React Native, and then you had similar changes happening on the Flutter side also. I've been doing Flutter since 2018 or so. I published in open source projects, and been working with this for quite some time. Built a lot of not a lot, but a couple of mobile apps which have given me enough experience to talk about this. At the same time, there's also been developments on other frameworks, like Android has come up with, Compose. Then Kotlin is doing the same thing with multi-platform. Then you have Swift UI, which is again very similar in nature and kind of in practice contains the same building blocks like Flutter. So if you look at all of the building blocks today, right? I mean, all the UI frameworks today, they are all having similar kind of building blocks. They all come up with a very rich component library. They all have focused a lot more on data and flowing the data into your application to different parts of your application. And then creating an interactive look and feel where there is first-class citizenship given to animations, transitions, gestures, and all those interactive features which are kind of expected today in mobile platforms, right? At the same time, creating a platform which is very easy to kind of integrate and add your own custom plugins and custom behaviors to do things which are very unique to your business and companies. So in general, if you look at it, and if you want to compare Flutter with others, I think it's the comparison is kind of differentiates itself in few ways, especially the way you develop and the kind of development cycles and workflows that you have. With Flutter, I think they kind of nailed it totally in terms of how quickly you can make changes to your source code and see those changes on the simulator or inside your mobile app if you're connected your device to your laptop, right? You can actually see those changes in live. And that's a great way to kind of bring a designer together to fix issues and try out different styles, a few different layouts and variations. And if you build your processes and widgets in a certain way, then you can actually experiment with swapping out widgets completely and see how your screen changes based on the data that you are receiving. So I think in terms of development workflows, I think Flutter is fantastic. The language Dart is very similar to any other language out there, right? I mean, C#, Java, JavaScript. It's all an inspiration over here. And I think these languages kind of are moving towards a place where it is giving more preference to UI constructs as a primary language feature, right? If you look at the Dart as a language, and if you see the UI tree, it looks very hierarchical, right? And the language itself supports it by allowing you to create a nested structure, allowing you to have arrays and collection literals and an ability to do filters and stuff inside a collection. And there are a lot more features added in the future also, like algebraic data types. You'll also have very complex pattern matching, which is very common in JavaScript today, but eventually will come into languages like Dart. Swift already has it, Kotlin already has it, Java 17 already has it, right? So the complex pattern matching, which will come eventually to all these languages. So all this will actually help you in writing your code in a better way and creating a lot of clarity between what is there in your mind and what gets eventually translated into the code. So that gap that exists in between what a language can express in terms of your ideas and how much of the gap that exists between what you have in mind and what you write in code, that is reducing dramatically over the years. And I think with these languages and frameworks, and I think it will be a front-end haven which is getting created right now.
Yes, definitely. I personally have tried Kotlin, but not Java, and I felt the same way in Kotlin, like while I was learning Kotlin. But I reverted back to Flutter because it was more friendly for me to have it like a cross-platform development thing. So I continued with it. Okay, so in the meantime, guys, attendees, you can post your questions in Q&A tab. There is a separate Q&A tab in the chat section. We'll go through that as well. Meanwhile, we are going through the questions which we prepared. So yeah.
Yes, sir. Sir, we came to know that you are leading the development of the Tata Super App. So can you give some insights on that and information about SuperApps?
Yeah, I mean, without revealing too much, I can definitely tell you what the super app is and what is the concept of a super app, right? I think it's anyone's guess as to what is a good super app or what is a super app in general. But the idea is, I think in India and across the world, what's happening is that the functionality that you expose in an app is kind of growing over time, right? Even if you look at current state of apps that we have today, Swiggy, Zomato, Flipkart and Myntra and what others are there. All these apps are kind of converging to a point where they become more of a lifestyle application than being a single purpose application, right? Even though you are a fashion, you're browsing for fashion objects, products, you will eventually go into other areas which are not related to fashion, but you're kind of interested in fashion, right? So you will probably go into movies and entertainment and trying out styles which are used by movie stars, and not necessarily just browsing for products inside your catalog, right? And then your lifestyle also extends into other areas, like you would want to take a ride somewhere, you would want to educate yourself, you would want to look at Instamart or Instacart kind of a quick purchase from nearby stores, right? So even if in existing day today, we do have super apps, but they're not called super apps because they just started out being a core application. Like Swiggy was purely for food delivery. Zomato also was for food delivery and for curated restaurants and menus. But eventually has gone into doing other things because of COVID and other situations, right? They all have gone into making delivery as a side function, along with food delivery being their primary function, right? So super app as a concept evolves over a time. And Tata is in a very unique place given this particular situation, right? if you look at Tata Group, we have about 120 companies, and they're all consumer brands like Tata, Tanishq, Westside, Chroma, Tata Click. You also have other areas like Jaguar, Land Rover, Tata Motors, and as we call them. And then we'll get into other areas also, Chroma for electronics. And there's also acquisitions that are happening like Big Basket, 1MG, and Cult. So if you look at all of these things put together, we have a big portfolio of individual services that can be offered to someone, right? And the way the Tata platform is built today is that if you go to Chroma and let's say you buy a laptop, you'll obviously earn some points, for buying it. But you can't use those points in Tanishq or buy any groceries in Big Basket, which is a huge problem, right? Because you earned those points, but you're able to only use those points inside the store in which you bought it, right? Or inside the brand in which you bought it. So we want to create a experience where you can actually earn points any of the Tata companies and also burn points in any of the Tata companies. So this creates a very blended, seamless experience for you so that you can navigate between various companies and earn and burn your points. So that's one aspect. The other big aspect is that each company has its own legacy and heritage, right? Taj Hotels, for example, has been for almost 100 years. Chroma has been there for almost a decade now. And Click has been there for about 5 to 7 years or even longer. Tanishq, Titan, Westside, all these brands have been there for quite some time. And have built their own customer base, right? Now, if you look at these products, and they're very distinct from each other. And if you want to do a experience of exploring the Tata ecosystem of all the brands, you'd have to go to these individual apps and do it. And that creates a very broken experience, right? So it only makes sense that we consolidate everything into a single application and give a unified experience to our customers. And that's the whole point behind a super app. And it's super because it's not just one app, it's a collection of apps. And that's why it's super.
Yes, sir. So this is kind of a off-topic question as of now. What do you think? Like, you made a mistake in your early stages, like you made a severe mistake in your early stages while learning or exploring this field. So that we can also get a glimpse of what went wrong at that time, and if that situation is upon us, then we can also relate to it and then work on it accordingly.
Okay, you're saying what mistakes I have made which you guys should avoid, right?
Yes, so yeah, basically that
Okay.
thing. So I don't think you have made mistakes, but
no, I have made hundreds of mistakes, and I don't remember the number of mistakes I made. I wouldn't call them as mistakes because everything is a way of learning, right? You only learn when you make mistakes. If everything goes well, then you're not learning anything, right? It's not, the world is not teaching anything, the experience is not teaching anything. So it's only when you make mistakes you actually learn something. So it's good to make mistakes, but what's more important is not to repeat the mistake too many times. You can make different mistakes, but not the same mistake. So mistakes are important, and in my case, I think some of the mistakes I made is not being too focused in academics early on. I realized much later in life that in academic is very important. And until I think 9th or 10th, I wasn't too focused on studies or academics in general. But after that, I became more interested because for the kind of stuff I wanted to do, it made more sense that I pick up some core subjects like mathematics and sciences and all of those kinds of things, right? So I think I would say focus a lot on your fundamental sciences and try to do things a lot more than what the academics or the institution is expecting out of you. See, everything is just a starting point. Your graduation is not the completion of something. It's actually the beginning of something else, right? When you have spent 4 years in an institute, or even 2 years if you're doing diploma or other kinds of postgraduate studies, your period during academics is only telling you and exposing you to different kinds of branches and studies and topics, right? But that is only to give you an exposure as to telling you that the world is very diverse and there are a lot of other things that you should be focusing on and look at. And those 2 years or 4 years that you spend in an institution is just giving an exposure or a taste to all those different topics. But once you get the taste, you do have to have applied science, right? You have to apply that knowledge that you have just learned. And that requires building the experience, right? So you can wait till you complete and graduate and then look for a job and then try to build your experience. Or you can say, you know what, I don't want to wait till my graduation. I want to start from day one to start using the knowledge that I have built, right? Which means I can start participating in open source projects. I can start being an intern at some institute where I just want to learn on how to build certain things. I can be part of these clubs like the GDG, where you can participate and learn about technologies much before you graduate, right? You can also go and be part of meetups and conferences and talk to people and not be shy, but just be bold enough to ask them questions, like you guys are doing right now, right? At my time, all these things are not even there. There were no avenues to actually go to any forum or talk to any expert in the field and get some, insider information as to what's going on. I could never ask, an expert and say, tell me what happens in the Tata world. It was never possible. There was no platform to do it. But now we have a platform, right? And that's a big difference in 2021 versus 1990s and 2000s. So what I would say is, don't be focused on your own academics. Don't try to just do what's given to you in the institution. Understand the fact that you will be respected and you will actually find something much bigger and better than what you want if you build the experience on the knowledge. Knowledge alone is not important. It's applied knowledge that actually gets valued. Even when you go out into the companies, right, in the interview process, they're only looking at how much of skills you have gathered, not just in the core fundamentals in terms of your data structures, algorithms, networks, databases, and all those things, but also how much can you actually apply. Given a problem, can you pull the knowledge from all these different sources and apply them to solve a problem? Right? It's not just UI or backend or APIs or databases or networks. It's a combination of all of them that builds complex systems. So are you able to understand the fact that a system requires multiple things, not just the things that you learned in your academics? So I would say learn these things and go very deep. And at the same time, try to build your experience by doing sample projects, open source projects, hackathons, participating in programming competitions, working with any senior and seeing if we can be of any help in building their projects, and doing and learning things well beyond what's taught to you in your institution. And I think that is how you would probably grow much faster than I did.
Yes, sir, that was a really good answer. And at your time, there was no expert, but we are fortunate that we have you to talk with.
Even I wasn't an expert, right? I wouldn't say I'm an expert, but I think I'll have more experience than expertise.
Yes, sir. So Vishal has asked in the chats that is it better to be specialized in one toolkit or API or learn a few?
See, it's again, when you're starting out, you should start with one, right? And that's so that you're staying focused on learning something and not constantly switching between 10 different things. So when you're starting out, you start with one, build some core knowledge, mental models about what the thing offers you. So if you're learning, let's say, SQL Server, I'm just picking some random technology over here, right? A database technology, not just front-end technology. Let's say you're picking, some database, RDBMS, right? Oracle or SQL Server or MySQL or Postgres. Then, spend some time learning what this particular database offers to you. Once you build enough of a confidence in knowing what it offers, then you can go into other areas like NoSQL, where the ball game has changed completely, right? The asset properties are not required anymore. You're valuing, let's say, consistency or atomicity or durability more than the other properties, right? And there is something like eventual consistency that creeps in because you have distributed databases and you can't have two-phase commit and things like that. So once you learn one database, you will be able to learn and appreciate the other things that are offered in the same field. So start with one, but eventually learn everything out there. Because they're all related. And the more you know, the more you will have an armor and ammunition to use in the battlefield of solving problems on real life, right? And in real life, your problem-solving abilities have to be very, very diverse. It's not enough to know only React, or Flutter, or Angular, or Swift UI, or Android. Just one is not enough. You should know all of them. To as much as possible, right? You don't have to be an expert in all of them, but you definitely have to be aware of all of them and what they offer. So that when the time comes, okay, instead of using Android, I can go and use React Native because it solves the problem much better, right? Because I don't want to build twice. Or I can use Flutter because Flutter gives me much nicer development workflows. The widget library is built in. I can create and publish apps very, very quickly, right? The awareness is more important than the expertise. But knowing everything out there in the field and being an expert or knowing one or two things very well will give you a good mental model. And it'll help you to also ramp up on other things which you don't know because they're all related, right? In fact, there was a very popular saying by someone, I think it's Richard Wurman or someone. He says, in order to understand something, you have to map it or compare it to something that you already understand. Right? So I'll just repeat it, right? In order to understand something, you have to compare it to something that you already understand. So if you want to learn Android, you have to compare it to something you already understand, which would be, let's say, some front-end framework, HTML, let's say, right? So when you're learning Android, you're always comparing, okay, oh, this has this widget over here, which is probably a div tag in HTML, right? This is a date picker, and that's a date picker I use in jQuery or Angular or React, right? So even in our minds, we are constantly comparing what we are learning with what we already know. And that's how you incrementally build your knowledge. So when you're learning 10 different things, pick one thing and then learn the second to the 10th thing by comparing it to the first one, and so on and so forth, right? So this way you will actually accumulate knowledge much faster too.
Yeah, that was actually really thoughtful, sir. It makes a lot of sense now because many people have suggested me to try other things as well, and I've tried some other things, but yeah, I have not went deep down into it. But yeah, it makes a lot more sense now you're speaking of it. Sir, next question. As a developer, there's something called solid principles and many things like that. So I don't think that is like put much more limelight on it. So can you just tell us what is that exactly, and how does it affect as a developer? Like, does it affect severely, or it's like a principle that must be followed, but if not, then it doesn't matter that much, something like that?
Yeah, I mean, see, principles are important, and the solid is one of the principles. But when you're building software, you have to focus on the principles, and principles will not change over time, but the manifestation of the principle could change over time. So let's take the example of solid, right? Since you brought it up, solid stands for single responsibility, open close, dependency inversion. L is for list call substitution. Yeah, interface segregation, dependency inversion, right? So that's just the expansion. But all these things don't make any sense unless you know what it actually means and how to apply it. Application actually is more important over here than just having a theoretical understanding of these principles. So let's take the first one, which I think is probably the most important of all of them, which is single responsibility. Now, what that means is that when you are building software, the software should just do one thing and one thing well. Right? If you're, and that you see everywhere in the world also, right? When you go and watch TV, the TV doesn't make coffee for you, right? It is not washing clothes on the side, right? It is not also a washing machine. A TV does only one thing, which is project pictures, right? It connects to some cable, it connects to internet, and probably delivers pictures to you on the screen, right? It is not already also becoming a washing machine or also becoming a coffee machine. That is not the purpose. The purpose is to be singular. Right? So when you're writing code as well, your classes, functions, variables, libraries, and even frameworks should be single purpose or having a single responsibility. A UI kit or a toolkit like Flutter should not also be an API server, right? Or should also not serve as a database. That doesn't make any sense. Because if you think of this principle a little more deeply, you realize that your human body is actually built on the same principles, right? Think of your eyes, nose, mouth, ears, arms, legs. They're doing only one function. They're not also trying to be the other organ, right? So if you just emulate the human body, software is just an emulation of real world. So if you try to emulate the human body, you will see that single responsibility becomes so pervasive in all of your code. And if you apply this principle well, then you will have composable software units. Right, you will have one thing that's done only doing A, the other thing is doing B, another thing is doing C. And every unit of work or a unit of software will have a very defined set of inputs and a defined set of outputs, right? And that way you can actually connect pieces together. It's like Lego blocks, think of it that way, right? So you're able to connect these Lego blocks. Individually, a Lego block may not be that useful. But when it's combined with other Lego pieces, you can build larger structures, even very complex structures, and even mechanical and moving parts, right? In Lego, all in Legos, right? So the way the Lego as a company has been built is to create very distinct unit pieces and then combine them together to create more complex structures. Software is exactly the same way, right? You create individual functions, classes, libraries, frameworks, and apps so that you can actually combine them together by flowing data between them. Ultimately, data is the most important thing, right? Data needs to flow from process A to process B and do some transformation in between, then go into other processes, right? So single responsibility becomes so useful. And in fact, it's something that is adopted very widely in the Unix world. There's something called as Unix philosophy, right? One of the first things in Unix philosophy is to be small and do only one thing and one thing well, and be able to compose things together. Like when you apply the pipe operator, you're taking the output of one command and passing it to the other command, right? You're able to do that because each command is doing only one thing. And you can take the inputs and outputs, and you know that the output of this command always in a certain format, right? So you're able to connect things where the output of one command fits nicely with the input of some other command, and the data nicely flows between these commands. So the pipe operator has been established so that you can now create individual commands and then create more complex scripts which combine a set of commands in a certain way, right? You're not creating one command that does everything. You are creating many small commands and the understanding that the assembly of these commands results in a more complex script, but not creating one complex command to start with. When you think of software also, it's exactly the same way you should be thinking. Think of the individual pieces or units of pieces, which need to be combined together. If you're building a super app, right? How would you go about doing it? You won't want to create one app that does everything, right? The app has to be built in such a way that you can actually take the inputs and outputs across multiple applications, multiple data sources, and combine them in a certain way. You have to think of composable software over here and composable units of work, right? Of course, on the UI, it looks like everything is blended together and it's all coming together very nicely. But behind the scenes, it's actually a huge Lego network that is building these things together. It's all composable software in the background. So that's single responsibility. Open closed is, it's more in terms of extensibility over here, right? The O in solid stands for, extensibility, which is if you want to make a change, you should not make a change by modifying the base code. You should make a change by introducing new code, right? So this way you're now touching the core. As an example, operating systems are built exactly this way using the open close principle, right? When I'm attaching a new hardware, I'm not going and recompiling my OS kernel so that I can attach the new hardware, right? Doesn't make any sense. We don't do that. We just plug it in. And what we do instead is we write a driver which connects to this new hardware. And the driver knows how to register itself with the core kernel and say, you know what, for this particular hardware, send all the interrupts to me and let me handle all the signals, right? And that comes as a plug and play. So it's open close principle applied right over there. It is open for extension, but closed for modification, right? Which means the kernel is closed for modification. We are not going about modifying the kernel every time we are attaching a mouse or a trackpad or a keyboard, right? But we are doing it by adding new things, by extending it, right? So it's open for extension. The kernel is open for extension, but completely closed for modification. So that is open close principle to you. List cost substitution is more for substituting between things, and this again is very common in the real world also, right? If you and that's what Big Basket would do for you. If you don't find let's say atta bread, the guy will call you and say, "Can I give you brown bread or can I give you white bread?" Right? He's able to substitute between atta bread and brown bread, and the reason why he's able to do it is because bread is substitutable. It follows the Liskov substitution principle. Both breads are built in such a way that as a person who is eating bread, you don't have to worry too much about how to consume bread A versus bread B, right? The brown bread is eaten the same way as you eat, let's say, the white bread. So because they are substitutable, you are able to do it so easily. In software too, you want to do something very similar, right? If you want to, this is very commonly applied in something called as a A/B test. I don't know if you guys are familiar with this concept of an A/B test, right? It's very popular these days. A lot of companies do it, on live production web servers and sites. So what do you do in an A/B test? A and B are two different experiments you want to run. These two experiments are very similar in their interfaces. So you can actually switch between A experiment and a B experiment by simply changing the implementation attached to the interface. The interface is exactly the same, right? Now, since they're substitutable, they follow the Liskov substitution principle. And now you're able to switch between the two experiments without having to do things fundamentally differently, right? As a software developer, you just want to attach a new implementation and everything works, right? You see that all the time in Flutter and other frameworks also, right? A button can be replaced. You can have an outline button, you can have an elevated button. They're all the buttons at the end of the day, right? Just the interface is the same, but the implementation could be fundamentally different. So that is Liskov substitution. And then you have interface segregation, which is more, again, going back to SRP, which is if you have a giant interface that has 10 methods in it, of which 5 are doing something, 5 are doing something else, then you're kind of combined a lot of things into one interface. So rather than having one giant interface, you break it down into smaller pieces, which is what you're doing with interface segregation. Segregate the interfaces so that it follows SRP, which is single responsibility principle. And by doing that, you are actually also enforcing open-close principle, so that each interface can be extended in its own way without having to implement all 10 methods. You can only implement 5 methods and get the extensibility that you need. So all these principles are related. That's what I'm trying to tell you. That solid is a set of principles. If you combine them together and create software, you will see that your software is easy to manage, easy to scale, easy to build as a large team, and easy to understand, most importantly. Right? Ultimately, what we do when we're writing software is we read the code 80% of the time, and you only write the code 20% of the time, right? So we have to heavily index on readability. We have to index on not cleverness, but index on readability, right? So that someone else who joins the team is able to understand what you guys have done. It's not a total mess, but it's very easy to understand. You have named your classes very nicely according to domain-driven design. You have followed the right principles of modularizing things so that one file doesn't have 10,000 lines in it, right? You've broken it up into smaller pieces. Interface segregation again, right? And you have put modularized things so that each does its own thing, which is single responsibility. So if you apply all these principles, I think Solid will make total sense, and you will understand why Solid becomes so critical, not just for object-oriented programming, but building software in general. And there's one last letter, which is D, which is dependency inversion. That is, again, going back to interface segregation, right? Instead of depending on the implementation, you depend on an interface, right? That way, if the implementation changes, your code does not have to change, right? Because you always depend on the interface. And you see this very common again, right? If you look at JDBC as a library, JDBC as a library has absolutely no implementation, zero implementation. It is full of interfaces. When you depend on a JDBC driver, you're only depending on the interface, and a JDBC driver will actually provide the implementation for it. Right, so if you can connect using the same JDBC interface to MongoDB, you can connect to Cassandra, you can connect to SQL Server, Postgres, whatever databases you have over there. So I think these are all the principles, and you can see how software has been built over the past several decades to use these principles very effectively. There are many more. For example, don't repeat yourself, and keep it simple, and you won't need it on day one. Like all these are principles, right? Start with simplicity and build complexity over time. But also note that software development is not about reducing complexity. The real world is inherently complex. So you cannot reduce the complexity, right? If you're building a tax management system, tax regulations are plenty and they are fundamentally complex. So you cannot change the complexity of your real world. But what you can do is manage the complexity in the way you write your code and build your software. So software development at large scale is more about managing complexity rather than reducing complexity.
Yes, sir, that was quite informative. There are many questions flooding in the chat box.
Okay.
Anirudh has asked, how mutually exclusive are UI and app development? Can I learn UI without having to learn app development?
Yeah, see, application is what the consumer sees. Right? When you talk about an application, ultimately you require to have a user in the picture somewhere, right? There is a role that the user has to play. Otherwise, the application will not move forward. Otherwise, it'll just be a backend process, right? Which is happening on a regular basis, or listening to some events coming from some notification somewhere and doing its job. When you talk about an application, fundamentally a user is needed to drive the application, right? If I open up a e-commerce app, it is not going to automatically go to products and add it to cart and check out on its own, right? Like a user has to do it, right? And the way an application will move forward is through an interface, a user interface, right? So they're not mutually exclusive. I think an application to work, you need to have a user interface. And the user interface need not be visual, by the way, right? We are also used to seeing the screens. So we think, a screen is your primary interface or user interface. But Alexa is also a user interface. Command line is also a user interface, right? Calling someone across the street is also a user interface, right? We're using language and sounds to communicate with them, right? So anytime you want to drive behaviors at a user level, you need an interface, and the interface could be in the form of pictures, sounds, actions, gestures, anything that can get the idea across and the communication across, right? Even email is user interface, by the way. If I send an email to you, I'm somehow communicating with you and making you do certain things, right? If I say, come to office tomorrow, then that's a communication sent over an email interface, right? Ultimately, you read the text in some email client and then make changes in your mind. Oh, I need to wake up early and go to office tomorrow, right? So through interfaces, you're able to drive behavior, and applications can drive behavior through a user interface. So they're kind of required in order to get things done. But fundamentally, you need a interface, but the interface need not be visual. There are other ways of creating interactions.
Yes, sir. That example of talking over the street was really good, actually. I never thought of that way in that perspective, but yeah. Also, we have a question from Krishna. How can we keep on upgrading ourselves? Like, we can see every 3-4 years, new technologies are developed, and it's too large, and it is to large extent replacing existing technologies.
Yeah, so see, the way you should upgrade is first of all learn the fundamentals, right? If your fundamentals are weak, then it will be very hard to follow what's going on, and everything will look new all the time. Now, if I change the paint of a building from white to, let's say, blue, then the building has not changed, just the paint has changed, right? But to make that observation requires you to understand the principle that the building is the same, right? So the fundamentals have to be clear over here. If you don't know that building's paint can be changed, then you will never observe the fact that it's changing, right? It is some things are fixed and some things are always changing. So technology also works in very similar ways, as in there are fundamentals that don't change that often. They change probably every 5 to 10 years. Like machine learning is a fundamentally new paradigm that used to exist, by the way. 30 years back, we still used to have artificial intelligence and deep learning, and all these things used to actually exist. It's just that it never came to the mainstream. It was never part of our curriculum. It was there as a research topic, but never really taught as something that you could do on a regular basis, right? We didn't have toolkits and frameworks and different kinds of IDEs built around machine learning, but now we have it. So fundamentally, nothing has changed. It's still the same, but what we have now is new paint to interact with the fundamentals, right? The paint interacts with the building. So you have IDEs, you have Jupyter notebooks, and you have Python toolkits. All these are interfaces to interact with the fundamental, which is artificial intelligence, which again boils down to fundamental mathematics, right? Everything is math and numbers at the end of the day, right? If you look at a deep learning network, it's just a hierarchy of numbers, each telling you that certain features are important versus certain features not being so important, and so on and so forth. So fundamentals existed even 50 years back, but the interface to use those fundamentals has changed quite a bit these days. So when you want to learn something new and keep yourself up to date, knowing the fundamentals, for example, mathematics, computer science, data structures, networks, databases, user interfaces, artificial intelligence, right? The physics and chemistry. These are all fundamentals which will be used to learn new things and new technologies. You would not be lost if you realize that Flutter as a framework is not doing anything fundamentally different, right? All it is doing is painting pictures on the screen, which requires you to compose something called as the frame buffer, pass these pictures over some pipeline from the CPU to the GPU. The GPU then renders it over its hundreds of cores and makes it faster, right? So this is the fundamental pipeline. Now, on top of this, you can build several toolkits that make this pipeline easier to manage. Again, manage, not reduce the complexity, right? Flutter reduces the complexity dramatically. React Native reduces the complexity dramatically. Swift UI is doing the same thing. Jetpack Compose is doing the same thing. Kotlin will do the same thing eventually, right? So all these are interfaces to interacting with your hardware. And the hardware has not changed. I mean, the GPUs have just gone in the number of cores from, let's say, 512 cores to 1024 to 248 cores, right? 2048 cores. So the hardware is just changing, not at the same pace, but at the same time, you are seeing that the interfaces to utilize the hardware is becoming simpler to use. So technology is becoming simpler over time. if you understand the fundamentals, then it won't be so hard to follow that these are all just making it easier for you.
Yes, sir. That was a very good example which you gave of the paint and the building.
Yeah.
So Subhranshu Pati in the chat box has asked that will progressive web applications ever overtake native apps?
Why do you want to overtake? Why does it have to overtake? Right? So everything has a purpose. Not everything can be a native app. And should not be a native app rather, right? Because there is a cost involved and some friction involved in installing an application, finding the application on the App Store, installing it and waiting for it to download. And then maybe you have to also log in and register, and it's just too many steps, man. I mean, it's just waste of time sometimes, right? So unless it's absolutely critical for you to do your work and live a life, you should not be downloading applications. It should just be use an application, throw it away, right? Just for the task at hand. And for those kind of things, a PWA can work much better, right? Where there is no involvement or a need for you to log in or register or download anything. You just open up a URL and the app is ready for you, right? And if required, you can log in, but that's again how you build the application. If you're in an airport and when you have a very weak Wi-Fi connection and not much of a data network left, you want to quickly open up a page and get some things done, right? You want to see the flight schedule. I don't want to go to the display which is like 100 meters away. I can just open up an app which is just a PWA and then get the information right away, right? So I don't want to install by going to an app store, downloading an application, waiting for it to install, open up, log in, register, then see the flight details, right? That's just too much. So rather I could just go to a URL and just instantly I have all the information with me. So everything has a role and a purpose over here. Technologies are built to solve needs of human beings, right? And our needs are quite varying and diverse, and they keep changing throughout the day, right? A native app developer will also want to use a PWA because he doesn't want to create native apps all the time, because it requires you to submit the app to the App Store, wait for the approval, then see it on the App Store, then wait for 48 hours for all the networks in the world to propagate through CDNs, and then eventually download the app. Whereas if you have a URL, it's very easy to just pass the URL, and most domain name servers are already public, right? So the refresh should be within few hours or within minutes sometimes, and you have access to the URL for all your customers. So understand the need and purpose of these technologies. They are not meant to replace or compete with each other. They are simply meant to complement and sometimes even augment each other.
Yes, yeah, that whole long step for a query of flight, that was really good example. And so this is sort of a beginner friendly question. Arun Ritesh, I hope I'm not butchering your name. So he's asking, for someone who has not started app development, what would be the reason to get me into this? What is the philosophy behind app development?
There's no philosophy, it's only interest, right? If you're the fact that you're asking that question is that you're interested, I think you should just get started. The bigger question is, what should you start with, right? It's not that whether you should start or not, it's what you should start with. And what should be the first step that you should take? I think the first step should be whatever is near you in terms of your ability to get the toolkits, download an IDE, and awareness, right? So if I'm starting with, if I'm only aware of React, I'll probably start with React, right? Or Svelte or something else which I'm aware of, like say Vue.js. So if you're aware of something, your awareness is your inner circle, right? This is what you know for a fact. So you can actually start with that and then learn it. And over time, by learning that, you realize that there are other things also outside that circle, right? So the circle expands now. And now you can get into native app development, like mobile apps, right? You can get into Flutter and React Native or do Swift UI or something else on Android, right? And then when you do that, your circle expands even more to include additional libraries and frameworks and databases and other kinds of systems you need to integrate. But then that happens, and it expands even more to include, companies and integrating, URLs and APIs across multiple systems. And when that happens, then you talk about scale, right? Right now, I'm doing the app just for myself, but eventually I'll be building this app for thousands of users, then tens of thousands of concurrent users, and then millions of users and billions of users, right? What needs to change in order to make this happen? Should I still use the same infrastructure, same architecture, or should I just change things fundamentally? right? An app that can serve 1 billion customers is not the same as an app that can serve only one customer, right? The whole infrastructure, which is like an iceberg, which is sitting behind the thing which is exposed over the surface, is quite different, right? So start with something simple that is nearby to your mental abilities and whatever capabilities you have. And as you start learning it, your capabilities will improve and expand. And as your circle expands, your capabilities expands, and it's a vicious circle over there, right? It's a feedback loop over here. The more you know, the more you realize there's more you don't know. And then you keep on going further and further and further.
Yes, sir. Nikhil Govind in the chat box has asked, do you recommend web development or app development for a beginner in the development field? And can someone switch from web development to app development and vice versa? And what do you think are the career opportunities for both?
Yes, so you should learn both, not one or the other. Start with something that you want to do now, and then once you learn it, as I said, you can learn the app development also eventually. Or if you're starting with app development, you can eventually learn web development also. And the opportunities exist for all of them, right? And whether you should do this or that is not the question. Is when should you do this and when should you do that? First, start by building the awareness about this and that, and then realize what is immediately needed versus what can be needed in the future, and start accumulating knowledge slowly on the side. So there is something called as a tunnel vision, right? In a tunnel vision, you can only see what's there inside the tunnel. You don't know what's happening outside the tunnel, right? So don't keep tunnel vision. You keep vision with peripherals on the side, right? While you're focusing on this thing, be aware that there are other things on the side also, which is what our human brain does, right? Your eyes are allowing you to see right now on the screen, but you're also aware of your surroundings. You're also aware of the fact there is a cup on the side, there is a table on the side. That awareness has to be there. So have peripheral awareness, but have a strong focused vision on what you're doing right now. And you can switch between them whenever the focus changes or the priorities change. It's like, and if you do only one thing, it gets boring after some time. Now imagine eating dal rice all 365 days of the year. It gets super boring, I'm telling you, right? You want to keep switching it, right? You want to sometimes have biryani, sometimes you want to have chapati with paneer, makhani or whatever. And then you want to have a dessert also on the side. Even desserts, you want to have multiple choices. And even the kinds of breads you want to eat, you want to change over time. So doing the same thing over time, of course, you'll become an expert at eating chapati, but it gets very boring also. You should keep switching things so that there's more variety in life and there's more fun also.
Yeah, so Ritesh has asked this question. This is, I believe, on the continuation with the solid principle. How to achieve polymorphism with interface segregation principle, the I and the solid.
Yeah, I mean, they're all related, right? If you first you have to dissect the word, what is polymorphism? Poly means many. Morph means a shape or a form, right? So you have many forms and shapes, but they're all bound by a common interface, right? So the classic example of a car and an engine and all those things is good, where you have a common interface and can keep switching between different cars. So let's take a more realistic example of that car, because that's what is taught in the object-oriented classes, right? They keep giving this example and butchering it to death. So let's take a more realistic example. If you learn how to drive, let's say Pulsar, right? If you know how to drive Pulsar and you know how to change the gears and you know how to handle the brakes and throttle things and fill the petrol and manage and maintain a Pulsar, it's not too hard to switch to some other bike later on. I can switch to a super bike, which will just have more CC and more power, but it's still fundamentally the same way of driving, right? The interface is the same. It still has a brake, it still has gears, it still has a tank for petrol. Eventually it will become electric, but that's a different story. It has 2 wheels, potentially even 3 wheels. It has more storage maybe, to put things. But the interface is fundamentally the same, right? The interaction is the same. What has changed is the face paint. Instead of calling it Pulsar, it is being called, let's say, Hayabusa, right? So it's not changing. It's polymorphism right over here. Many forms, common interface. So interface segregation is probably not the right linkage over here. It's more to understand that if you have a complex interface, you break it down into smaller pieces so that it's easier to manage. Again, SRP, right? Single responsibility principle. If you design things where you build such that you have a very strong core and a strong foundation and a single responsibility, you can compose things together to build larger structures, right? And the spare parts is again an example over here. I can change my tires. Although Hayabusa can come with some Michelin 3 tire, I can probably switch to a Goodyear tire also, not a problem, right? Because the tire is a single responsibility principle, right? It's doing only the job of a tire and it follows a standard interface. The interface has been segregated enough so the tire interface is different from the engine interface, right? If you have one interface that does both engine and a tire, that's a problem. Then replacements are not easy. So substitutions are not easy, which means you'll violate list cost substitution, right? And also open close principle will be violated because you cannot now extend things without adding things more easily. So all these things are related. In life, everything is connected, right? And so are these principles. So once you start understanding the larger connections that exist between various things, you'll start to see the importance and relevance of each of those principles. I hope that makes it clear enough.
Yes, sir. Yes, sir. It definitely makes a lot more sense. Also, I know we have a lot more questions actually in the Q&A section. I think, sir, you can have like meet till 5:15 if you are free. I know you are a very busy
Sure.
person and even it's Sunday. So yes, another question from Vimal is, I think this question is asking on the continuation of human behavior, which you talked about, like how we should design the app, like how we are communicating to someone like a UI. And you said the example of communicating to other one across the street. So he's asking, sir, should we continue learn about human behavior while learning app development?
Absolutely. So the human body is a fantastic piece of engineering and a fantastic piece of design, which has evolved over many thousands and millions of years, right? And certain traits have been boosted and certain arms and organs have been given special functionalities and features, right? I'm talking in terms of software right now, right? The human body is a feature-rich package over here, right? And every feature is uniquely designed to serve a very specific purpose. So if you understand the design of the human body, I'm not saying you should actually go and take a class in anatomy and understand the human body as a medical student, but understand that the human body has been designed to give you a composable piece of software where individual parts do individual things very uniquely well. An arm can't become a leg automatically, right? Although you can if you try to walk on force. But an eye cannot do the function of a mouth, right? You don't eat from your eyes. So if you understand, the software can also be built in a very similar way. Just look for inspiration at the human body, and you will see that a lot of the software that you build can be built as the organs of a human body, which are very single-purposed, can compose together. For example, if I lost my arm, very bad example again, I can substitute with a prosthetic arm and still do the job of an arm, right? The reason being that the brain actually contains these signals and they're constantly sending the signals on the arm. Just that there is nothing reacting at that point, right? But the brain has not lost hope that it will not react. It just keeps on sending the signals. But one day when you attach a prosthetic arm, suddenly the things start working. And you've seen examples of that on YouTube and LinkedIn and all those places where people show how a prosthetic arm behaves like a regular arm. Because if you can tap into the signals, and signals are data, by the way, right? If you give the data, you can build an interface on top of the data to do the right thing. The brain is sending data in the form of signals, which is saying, move this finger, bend this finger, or form a wrist, and so on, right? Those are all signals being sent as data. If there is an interface, which is the prosthetic arm, responding to the data signals, it can do the job which the brain is asking it to do. And it just magically feels like you're, making the arm move. But guess what? You are just connecting to the signals in the brain. It's all electric signals, by the way. Right? So you can actually create complex pieces of software by comparing it to the human body. And if you can study the body, then you can find parallels and see how you should be writing code and managing this piece of code by comparing it to the way you maintain a human body. Right? And everything in life is actually a feedback loop. And what I mean by that is your human body is regulated constantly, right? If you eat a lot, then you feel too full and you won't feel like eating anymore. So there is regulatory feedback cycle given to you from the brain that your stomach is saying, I can't take it anymore. So stomach says, don't eat, right? But if you don't eat for 2 days, then the stomach says, eat, get more sugars, right? So there's a constant balancing feedback loop that is happening, that constantly being, pulling data from all the different parts of your body, connecting it to the brain, and the brain is sending signals down to all the parts of the body saying, now do this. Telling it to your mind that, okay, now go and eat, right? Which means you'll start searching for an app like Swiggy or Zomato, or if it's a super app, maybe you'll do everything in one place and, do things and, serve your needs of your brain. So yeah, definitely learn, and I'm sure you'll find inspiration when you start comparing things.
So Nicholas Emmanuel has asked in chat box. This is a beginner-oriented question. He says that I actually study in first year of VTech. Which programming language will you suggest that we should master first?
I would suggest start with Lisp. The reason is Lisp is one of the simplest languages in terms of syntax, yet is very complex to master, right? The S expressions that you have in Lisp actually can be used to construct very, very complex pieces of code. And an entire Lisp code can look like a bunch of parentheses, wrapped inside parentheses, right? Take a look at Common Lisp and learn that language, and you'll see that the elegance of software can come by composing gigantic things by smaller things, right? If you know the fundamental building blocks of Lisp, you can actually append things to the end of a list, or you can add things to the head of a list, right? And then create longer structures. And these structures can become the child of a parent, and the parent can be child of somebody else, right? And that's how we create very complex object structures and data structures in general. So Lisp is a wonderfully simple language. So you don't have to sweat yourself in learning the syntax. You focus more on the fundamentals, on how to write code, how to solve problems, using a simple language like Lisp. And if you can solve it in Lisp, then you can also adapt a language like Clojure, which is again based on Lisp, but works on a JVM, so that it gives you nicer tools and IDEs and stuff to work with, right? Once you go past Lisp, your brain will start thinking functionally, which is how do you create small functions that can wrap bigger functions, which become arguments to other functions, right? We are so used to thinking about arguments being objects and data, but even function is an argument, which can be passed to other functions, right? So you have closures in place, and closures are fundamental in JavaScript, and also in all the other languages like Swift and Kotlin, Java, C#, etc., right? But all these fundamentals come from languages like Lisp, which was created by John McCarthy many, many years back, right? Back in 1958 or something, right? And it's still very powerful. In fact, one of the first C# compiler at Microsoft was first created in Lisp, right? Because it's easy to experiment with a simple language like Lisp to create even parsers, because parsing is easier with a toolkit like Lisp, where the lexer and parser is very simple, right? So you can actually create very complex pieces of software just by using Lisp. And then on top of that, you can adopt other languages like Haskell and OCaml and learn more functional things. Once you train your brain to become more functional, it's very easy to adopt object-oriented software. But unfortunately, our educational systems are doing it inverse. They teach you C, which is probably a very imperative language, which makes you think at the level of a hardware, not at the level of software, right? It is a very, very simple abstraction over hardware. So you end up doing a lot of things like memory mapping, paging, all that management of memory and code, and it's very, very simple. So you don't have modularity so much. So you have to create your own ways of creating conventional modularity, whereas languages give you modularity built in these days, right? So I think institutions are not doing it, but you guys should take the lead and learn functional languages first, and then pick up object-oriented languages as the second step, right? So learn functional languages like F# or Clojure or Haskell or OCaml, and then jump on to C#, Java, Swift, Kotlin, and so on and so forth, and even Jelly JavaScript too, right? By the way, JavaScript was also modeled after Common Lisp. The Common Lisp object model, was the fundamental inspiration for JavaScript. So it's the same structure, like the closures in Lisp become the closures in JavaScript, because it's all functional at the end of the day, right? So focus on functional languages first, and then jump into object-oriented languages. And when you jump into object-oriented languages, also learn programming language theory. I don't know if it's part of your curriculum. PLT is actually a very important stream inside computer science, which will help you think very differently. Ultimately, the real world, software development is about modeling. right? How do you create abstractions? How do you take a real world problem and create in small pieces called the abstractions or the building blocks on which you can create your software, right? And this you will get a better sense of doing, when you understand PLD, which is programming language theory. Functional languages train your brain to think more functionally in smaller units. And by combining with the superpower of PLT and functional programming, you will have a powerhouse of knowledge to solve pretty much every real world problem out there.
Okay, so that was a good trivia for us to know about Lisp, and that JavaScript is also originated from some part of Lisp. I actually didn't know that. I have a question in my mind, sir. Like, if we develop an application, we host it on Play Store or whatever service we host it on. Like, we roll out updates. How do we like keep a balance between quality and the speed of the update?
The balance is a little hard sometimes, but quality matters more these days than speed. Because let's say you do something very quickly and put it out, but actually has some fundamental bugs. It can actually destroy your customer's data. It can break the experience completely. It can cause a lot of exceptions at runtime due to the untested behaviors that you deployed, right? So there is a bigger cost to rolling back and a bigger cost to deployment if you don't test it well, right? So although you are able to deliver things fast, if you did not go through the proper channels and processes, you can deploy something which can be very, very harmful for your reputation and detrimental for the customer's tasks, right? It could eat up data, it could destroy the overall behaviors, and it could probably do a lot of nasty things, which it could even expose a security exploit, which means somebody will hack your computer or a laptop or a phone, and then suddenly everything is gone, right? Just because you deployed something which did not match the quality gates, right? So I think these days quality is more important. The speed, I think, can be controlled a little bit. So you have to be very careful when you want to go fast. Be prepared to fail fast also, right? And when you're failing fast, you have to again recover fast as well, so that your customers don't feel the pinch, right, or feel the blip, because the hackers and all the people waiting outside for you to fail are just waiting for the opportunity to see what kind of an attack surface you expose to make their first move, right? So I would say over-index on quality first, and let speed be a close second.
Yes, sir, that was quite insightful. Naman has asked in that React Native has converted to a community-driven framework. Will this be a disadvantage over Flutter, which provides many official packages?
Yeah, see, so React Native started earlier, right? So obviously the community is built up also earlier. And that's how the world moves, right? When I only introduce one way of playing a game, then everyone plays only that game. If a new game comes into the picture, then it takes time for the people to also learn the other game and then realize that this game is better or worse than the other game, right? You only understand new things when you can compare it to things you already understand. That's what I said earlier also, right? So Flutter will now be compared to React Native, which is exactly what you're doing, right? You're comparing Flutter to React Native because you probably know React Native first. And that's how the world will progress forward, right? There'll always be something new coming up. Once Flutter becomes a mainstream adoption and there's a community built around Flutter, somebody will introduce something completely new. And then I'll get a question like this in 5 years, which says, hey, this new XYZ framework has been introduced. How does it compare to Flutter, which already has a big community? It can happen. Definitely can happen, right? So you have to understand that, the world always moves in these kind of ways. Right? It takes time for things to develop. It takes time for things to mature. But once they mature, they're introduced into the mainstream, and people take time to adopt. Right? There is a time between adoption, between when React Native was first came into the market until it came to a point where everyone was talking about it in companies and in networks and developer clubs, and also in jobs and hiring portals and all that. Right? So it is not that you introduce React Native and suddenly the next day the whole world has switched over. It doesn't happen that way. Everything has latency over here. Same happens with Flutter also. Flutter is fundamentally a different toolkit, a different way of doing things. And better or worse, I don't know. You guys decide that. But it's definitely something new. So it will take its own time to reach a level of adoption. But the adoption is also going very fast, right? Google is doing a lot of fantastic things to make this toolkit fundamentally very useful, and by baking in things in an official manner, right? Whereas React Native, you have very limited widgets, and you have to go to plugins and libraries to augment your application with the missing widgets and libraries. Flutter comes built in out of the box. So you get a benefit of speed. You get a benefit of well-designed, officially curated set of widgets, which obviously will have higher quality compared to a community package, which is probably not maintained as closely as a big company like Google. So you take a pick, and try both and see what works for you. And I'm sure every community will grow the same over time. Even the GDG club that you are part of right now was not the club like it is today, right? It started off being one person at some point. Google coming and saying, what, why don't you start a club over here? Somebody getting appointed as an ambassador. And then we get few more people to join the club. And then we launch our first meetup. Then you need to find some person to talk about that meetup. Probably was your school principal or your dean or HOD or somebody came and gave a talk. And that's how you spread the word about your club. And then more people came in the next year, and they started being part of this committee, right? And then that thing grew and grew and grew. And over time, now you have a self-funding, self-organizing, regulated committee and a group where people are happy to come in, participate, learn, and grow over time. So everything takes time. There's a latency between something getting introduced to something getting adopted. And same happens with Flutter, and I'm sure it will happen to a lot of other things in this world.
Yes, I also actually believe that trying every other way is the way to judge everything. Like, you can't really say about anything without trying it. So yes, sir.
Yep.
Also, Kevin has put a question, and it has gotten 7 likes very quickly actually. So what should be a roadmap for a beginner to learn app development? Like, how should we approach step by step?
Yeah, that's actually a very important question. I'm glad you asked, Kevin. I think it's a very relevant question for everyone also. We have a lot of choices these days, and also it's very easy to get lost with choices, and which makes you think longer than you act, right? So you think, okay, should I use Flutter? Should I use React Native? Should I make a web app? Should I make a PWA or a native app? And if I pick a native app, then what framework should I use? Whether I should go with pure native or cross-platform, and then which language should I use? So should I use Java or Kotlin if I'm picking some Android? And then what library should I pick? What IDE should I use? VS Code or IntelliJ? What font should I pick in my editor? What theme should I apply to my editor? Dark theme or the light theme? Should I code in the night or during the day? Should I sleep first and then code, or should I eat first and then code? Right? Too many choices, man. I think it just goes crazy very quickly. So the way you should think about app development also is to start with basics, right? Keep your scope very, very small. Take baby steps. And I think it has been repeated many times with many people also, right? If you have an idea for an app, first start thinking about what data does the app need to run. Always start with data. Rule number 1, right? Don't start with the visual experience. Don't start with the UI. Don't start by opening up Figma, Sketch, or some crazy design tool and trying to create an interface for your application. Stop doing that. Stop it. Clearly. Start with data, right? Because app ultimately needs data to function. So start with your data. Start by modeling the data. What are the entities you need to represent on your application, right? If you're creating, let's say, give me an example of an app, let's say food delivery, right? Swiggy. If you're creating a new Swiggy app, the first thing I will need is what? Not the interface. I need to have a database of all the restaurants and the menus of all these restaurants, right? And I then need to collect this data in some harmonious, standardized fashion so that I can jump between restaurant A to restaurant B and have a consistent structure that gets shown on the UI. So I'll start by accumulating all this data first and understanding what is the structure of my data, right? Whether it's what are the fields and attributes, what is optional, what is required, and what is the overall interconnections and relationships with the different entities that I have in my application or in my data model, right? So in case of a Swiggy, you will have a restaurant. Restaurant has a menu, can have multiple menus. Restaurants can have other fields like when they are open, when they are closed, what are they known for, what is the star rating, where are they located, what are the pictures, what are the reviews of people posted who are eating at this place. so on and so forth, right? So that is the data you need to collect first. Once you have a rich data and you have created a model around this data, as in what are the entities, what are the relationships between various entities, and what is important, what is not important, and so on, then you have a good understanding of the entire space of the problem that you're solving, right? Then it's just a matter of mapping it to some interface. Okay, the restaurant needs to have a page, right? So I'll create a screen which has the restaurant name. I'll have a nice picture at the front, which is one of the photos I'll pick from the restaurant data model. And then I'll put some star rating on top of it. I'll give some fancy tagline. I'll show whether the restaurant is open or closed, and then have a section below which shows me all the menu items of the restaurant and the price of the menu items, whether it's a vegetarian or a non-vegetarian dish, and so on and so forth, right? This is all data, absolutely no UI at this point. So once you know your data, then it's just a matter of mapping it or projecting it to a interface, right? I'll take this photo URL from this data model and map it to this image object on my Flutter UI, right? It's just a mapping exercise at this point. I'll take that button and make it an add to cart button somewhere, right? And I can increase the quantity over there. I can select a menu item. I can go into a restaurant, see the photos. All the interaction paradigms can be built after that. So once you have a rich data model and you also understand the interconnections between the data models, then you can start building your application. Now, application entirely lives on data. Even an application like Swiggy, right? It will require other allied systems which are not its core functionality but required to do its job, right? Just ordering something and adding to the cart is not enough. Somebody has to actually deliver these things also, right? Your order has to be sent to the restaurant, and then someone has to be told to pick up that particular order from the restaurant and deliver to your house. So there's integration required with APIs. There's integration required with other systems. I need to integrate with the restaurant's management system and order management system, so that an order taken from the Swiggy app is put into the order management system of the restaurant. So the restaurant gets notified that an order has been placed. They start preparing the order, and then they send a signal to Swiggy and saying, I started preparing the order. Then Swiggy gets the event, and the event is shown on your UI. So all data, right? Signals. I told you about signals, right? Brain sends signals. Same way, your app and your systems, which are connected together, are sending signals to each other to communicate. And those signals, which are primarily data, are being surfaced on your UI, right? Once a person picks up your order from the restaurant, you start tracking the person on a map, right? So there's constant signals being sent from the app into the server, and the server to your application. So as you can see, I don't know if I'm making sense over here, but you can see that how data becomes the fundamental backbone on which you build interfaces that are simply reading the data and rendering as some widget or an interface on the screen. So start with data first, understand the interconnections, and then map it to some interface. That should be the path to building any application. Big or small, by the way.
So as you said, that data is an integral part while developing applications. So one question Ahan Banerjee has asked, what could be the type of data one needs for developing a social media app?
So social media is a very broad term, right? It is basically a collection of people who are coming together, spending time on some application where they have an interest in probably looking at photos or activities or doing something which works across a group of people, right? So when you talk about social media, the first thing you have to identify is what is the activity around which you're going to gather your customers, right? Twitter gathers the customers around news and activities of people's lives, right? Same happens for Facebook, right? People post pictures, what's happening in their life. I went here, I did that, I ate it, I brought this new dress, I took these pictures, I met this celebrity, so on and so forth, right? All their activities are getting tracked on the Facebook wall, and other people are tracking that, and they are pasting their comments, likes, etc., etc. So social media is essentially a gathering of people around some common activities. So if you're building a social media app, I think the first step is to identify what is the activity around which you want to gather people. Is it food, which is what Swiggy is doing, right? But they haven't built a social media application, right? It is a personal media application, not a social media application. If you want to create a app which kind of brings all the foodies in a group together, let's say in some city, then that's the social media application, right? You have now gathered people around some common cause or a common activity. It could be around like meetups where people are coming for conferences and knowledge sharing. It could be for biking or going for swimming or playing table tennis or badminton. It could be absolutely any activity, right? So first step is to identify what is the activity around which you gather your people, and then understand, what kind of data will be needed to represent that activity, and collecting the data from different people so they can be posted on the person's profile and allow interactions from the wider group of people with that particular person and the person with the wider group of people, right? And that is how you create a connected, socially engaging media application.
Yes, that actually makes sense. Okay, so guys, we will be taking one or two more questions and then we'll wind up because we have actually extended the limit, and it is quite generous of sir that he has extended his limit because he's busy also. So one question from Kaushal is, sir, is it necessary to learn cross-platform, or should I focus to the domain which I am pursuing to get better at it?
So I'll let you guys answer the question now. What do you think we should do? What do you think Kaushal should do?
I actually think he should try other things and keep everything ready. Like try other things and not expertise everything, like you said earlier, but also learn different things. Like you said once, we should actually try other things and then judge on that this will be helpful there, and this will be helpful there, and then work upon like whatever the problem we are facing in front of us.
Yep.
I think that's the
Absolutely. Try with something simple which you can get started, and then you can build on top of it, right? Think of the expanding circles.
Yeah, definitely, sir.
So Subhanshu has one more question. As you suggested that to learn both web development and app development, are there any overlapping libraries within the two?
Yeah, Flutter is one. It can do both web and native. React Native also does something similar, but it's fundamentally different to create a web view of it. But don't think of it that way. Think of the fundamentals. Web and native are just a projection mechanisms, and what I mean by that is, it is a framework to render to some screen, right? Web is a screen, native is a screen. Both screens can be the same or different, right? Web is just happens to be inside a browser. Native happens to be on the train window of your primary operating system, right? They're all screen-based interfaces. So I can use any framework, any toolkit to write to a screen-based framework, right? It could be a web framework, which can also be hosted inside an application shell and make it look like a native app, but could be a web app internally, right? Or it could be a native app, which is straight away using the native widgets and rendering the same data. As long as you have the data, and as long as you can map the data to a specific interface, you can project the interface on a web, on a giant, 30 by 40 foot billboard, or a small native screen, or an iPad, or it could be a command line interface, right? It all comes down to, what do you want to project your data on? That should be the question you should ask. Do I want to project on a web? Then use a web framework. If I want to project on natively, then I can use a web framework inside a native shell, or I can just write to a native app directly. So go back to the data first and understand, what you or your customers or your organization needs in terms of where do you need this data projected. If it's a dashboard, maybe it's better for the web because then I can just send a URL to everyone, right? If it's for personal consumption, maybe an app is better because then I can have rich animations, interfaces, a fluid look and feel, and delight the customer in a lot of different ways. So it all comes down to what is the purpose, and who is your audience, and what is the kind of data that you want to project, and how do you want to project.
Yeah. I have actually learned a lot about data in this talk. Actually, I didn't put much emphasis earlier, but it makes a lot of sense to make more emphasis on data rather than going for like problem, how do we solve it, and googling for stuff like that. It actually makes a lot more sense. I think that will also reduce the time taken to solve a problem. I think so.
Absolutely.
So yeah,
I'll give one little secret. One secret of UI development is to actually understand the data. The data science behind UI development actually is more critical than the UI science. If you can model your data well, if you can structure it well, if you understand the relationships and the importance of data very well, then projecting it to a user interface is actually the easy part. But most people make mistakes on step 1, which is why the step 2 is screwed up.
Yes, sir, yes, I can relate to that. Actually, I actually make that mistakes a lot of times. So I'll try to rectify it in the near future.
That's one of my mistakes too, by the way. You asked that question, right? So that's one of my mistakes I made long time back.
Okay, sir. Also, sir, here's one question about MongoDB. Rishit is asking, what are your thoughts on Kiwi MD integration with MongoDB or SQL? I believe he's talking about Kiwi material
No
design.
idea.
Yeah. So
Okay.
I think
I haven't used Kiwi MD, but yeah. But I think you can kind of break the question down, right? Thoughts on Kiwi MD integrated with MongoDB. What is Kiwi MD? Is it some kind of a store, framework, library? What is it?
As far I've heard about it, it's something related to material design, which is Google's design format. But I have not used it or discussed on it a lot in my free time. I'll actually look into it.
If it needs to be integrated, we can integrate it. It's all possible in software. It's all computer science at the end of the day.
Yeah, definitely, sir. Yeah, now there's only one question, so I think you can answer this. Nimish is asking, so is there any difference between backend for web and backend for apps? If there is there any approach to developing backend as app developer so that the performance issues are not there?
See, backend is ultimately data. Think of it this way, right? A data can serve and be projected onto web, can be projected onto a web app. So when you're building a backend, you're building a data store and you're creating an API for that data store, which eventually gets called from the client, right? So now if the data itself needs to be different for different applications, then you don't want a single interface that serves all your endpoints, all your clients, right? If you create only one REST endpoint, then it's only one way in which you can communicate. Instead, what you can do is you can create a GraphQL interface and let the clients decide what kind of data they want. And that way, the client gets control about what to fetch from the server. Or if you want to make the REST endpoint very powerful, then you can add headers and query parameters and customize it for the clients differently. So each client will call it differently with different query parameters. So backend is just data to me, right? It's just a very bad and a hopeless word for representing data. Think of backend as an API for data. That's it. Don't get lost in the marketing and the industrial terms.
Yes, sir. Okay, so I think we should wind up with this. It was a really good talk with you, sir, and especially I learned a lot in this session, especially about data actually. So I actually enjoyed your session a lot, and your cracking jokes, everything. That was really fun, and so we would actually love to get back to you sometime later. We'll try to organize something else later on if you are willing to do that. And yes, sir. With that note, I think we can wind up the session. Really appreciating your time to come here and then talk to us, do a Q&A section with us. I'm pretty sure everyone in chat also agrees to me that they have learned a lot of things here, and really fundamental things which are not available on the internet actually. I have never read any article or video emphasizing on data that much. Everybody is like, this is the UI, you can do this stuff with UI, this is the framework. But nobody has put much more emphasis on data. This is actually really eye-opener for me. And with that note, again, sir, a lot of thanks to you. And yeah, we can wind up with the session. And thank you everyone to join here. Also, guys, if you guys like this session and you guys want such sessions, you can talk to industry level experts and having experienced person like him, make sure to check out us on Instagram and join our community in Discord. We are very active in tech related fields, and you can also DM us your thoughts about the session and everything. Yes, sir. That was it from our side, I think, and we hope you have a great weekend.
All right. Same to you guys. And nice talking
Thanks,
to you,
sir.
and those wonderful questions from all of you. I think this is a great platform, and I think you should continue doing this with other experts in this field.
Yes, sir. Yes, sir. And also, I really like the way you explained some technical scenarios using real world examples. It is really a good way of learning.
Yeah, that's how we should learn. Always compare it to what's already there, right?
Yes, sir.